All right, everybody. Today we are going to start learning about complex numbers. This should be brand new for just about everyone, I believe. So we need to talk about this. What is a complex number? It all begins with the imaginary number, and you see SpongeBob there with his imagination. That's certainly going to help us. I just have faith. Okay. So here goes. Let's talk about powers for a minute. If I say x squared equals 4, could you tell me what x is? Can you think backwards and figure out what x is? A lot of you are saying 2, and you are correct. Some of you might be thinking in things a little bit differently, and you might say the answer is negative 2, and that is also correct because negative 2 times negative 2 equals 4, right? A power is where you multiply something by itself over and over. X squared means you multiply something by itself, and you get a given answer. So 2 times 2 is 4, but negative 2 times negative 2 is also 4. What does this have to do with imaginary numbers? Nothing yet. Let's talk about x squared equals 1. What number times itself equals 1? You could say that number is 1, right? 1 times 1 is 1. Or you could say it's negative 1. Negative 1 times negative 1, because a negative times a negative equals a positive, also equals 1. Often you'll see answers written like this: x equals plus or minus, in this case it'd be plus or minus 2, or x equals plus or minus 1. What does that have to do with imaginary numbers? Again, nothing. I'm just talking about powers in general, squares specifically, and I'm throwing in a little extra detail, this whole plus minus thing. Let's talk about x squared equals negative 1. Can you think of a number that when you multiply it by itself gives you negative 1? Could the answer equal 1? Well, no, because 1 times 1 does not equal negative 1, it equals positive 1. So that won't work. Could the answer be negative 1? Well, again, no. Negative 1 times negative 1 equals positive 1, because the whole phenomena where two negatives equal a positive. So this can't be the right answer either. So you might get frustrated and say, okay, fine, the answer is 1 and negative 1, because 1 times negative 1 equals negative 1. There, I did it. No, not really, because x squared means a number times itself. This is not a number times itself. It's a number times a different number. 1 and negative 1 are two different numbers, so you can't call that an answer either. So what historically was accepted as a fact, and what you've probably never even contemplated before in your life, is that x squared equals negative 1 has no solution. It can't be done. There is no number that when you multiply it by itself you get negative 1. It just can't happen. In general, we'd say something like, you cannot take the square root of a negative. It's not possible. You can't do it. No solution. Okay, well, someone historically, some mathematician along the lines, decided that wasn't good enough. He or she did not like the fact that you can't square root a negative, that it has no solution. So he or she said, phooey with that, I am inventing a solution. I am going to call the solution I, and that's going to represent the imaginary number. There is no real number that you can really multiply by itself to get negative 1. Therefore, I'm inventing an answer. It's not real. I'm going to call it imaginary. So what we have is the square root of negative 1 from now on is known as I, the imaginary number. You can think of I in a way kind of like pi. It's a letter or a symbol that represents a number. But it is a number. So from now on, you have to just accept that the square root of negative 1 is I. I is the square root of negative 1. It doesn't really exist in what we call real numbers, but it exists in our imaginations. It's called the imaginary number. So if I equals the square root of negative 1 from now on, that's a definition, that's a fact, that's a thing we have to know. We can now work with it. We can do math with it. One thing we can do with it is combine it with other numbers. So if you take a real number, add it or subtract it potentially with I, even multiply I by a number, you get a structure called a complex number. This whole thing altogether is referred to as a complex number. It has a real part and an imaginary part. The imaginary part has I stuck to it. So a plus bi is a complex number. So here are 3 examples of complex numbers. 5 plus 2i, negative 3 plus 4i, 5 minus 6i. Here, 5 is the real part, 2i is the imaginary part. Negative 3 is the real part, 4i is the imaginary part, 5 is the real part, negative 6i is the imaginary part. And we're going to today learn how to do math with these types of numbers, complex numbers. So here goes. In general, you can add, subtract, multiply, do powers, and divide complex numbers. Today we're going to focus on add, subtract, multiply, and powers because they're the easy ones. Tomorrow we're going to do divide. We spend one whole day on just one operation because it's the most complicated one. When it comes to adding, subtracting, multiplying, or dividing numbers, complex numbers, you treat I as though it's a variable. Yes, it is a number. It's the square root of negative 1, but you're not going to go and call it square root of negative 1 over and over in every single problem. You're just going to treat I like a variable, just like it was x. You learned how to work with x in pre-algebra, probably 7th or 8th grade, or maybe 9th grade, I don't know, when you worked everything out, but this is not difficult. For adding and subtracting, that's all you need to know. All you need to know, treat I like an x, like a variable, and you're good. For multiplying in powers, you also treat I like a variable, but sometimes you'll find that you have to simplify I squared or I cubed. Now, do I want to talk about that now, or do I want to wait till it comes up in an example? I think I want to talk about it now at least a little bit. Let's talk about simplifying I squared here. I'll do a little separate box. That's where this little mini lesson belongs. What is I squared? Well, remember, I is the square root of negative 1. So I squared would be the square root of negative 1 squared. And what do squares and square roots do to each other? They're opposites, just like plus and minus or times and divide. They cancel each other out. So the square root of negative 1 squared is just negative 1. So that means if you ever have I squared come up in a problem, it's a negative 1. You always simplify I squared to equal negative 1. What about if I cubed comes up in a problem? Well, I cubed is the same thing as I squared times I, or I to the first power, if you want to look at it that way. And we just got done saying that I squared is negative 1. So negative 1 times I is negative I. Therefore, if you ever have I cubed come up in a problem, it simplifies into negative I. And actually, there's a whole table. What about I to the 4th, I to the 5th, I to the 6th, I to the 7th, and it goes on and on and on. We're not going to worry about that today. We're only going to focus on these 2 facts. If you ever have I squared in an answer, you make it negative 1. And if you ever have I cubed, you make it negative I. Okay, let's get to some of these problems. If this was all confusing and man, you don't have any idea what's happening, hopefully as I start going through my even examples, it'll click. You'll see that parts of it are pretty easy. The complicated part you can just work at and you'll get through it. Also, you can go to YouTube and type in imaginary number or complex numbers and watch other videos, and that can also help you. But for now, let's get going. So, simplify. What does simplify mean in math? Basically, it's a generic term that means do math. Yeah, do all the math you can. So in number 2, negative 5i plus 6i. Well, first of all, those parentheses, they don't really do much of anything. This would be like saying, what's negative 5x plus 6x? I mean, you could answer this question 2-3 years ago. Negative 5x plus 6x is positive 1x. You know how to work with variables, therefore you know how to work with imaginary numbers. Negative 5i plus 6i is positive 1i, or just I. Let's check number 2, and there it is. So we're like combining like terms. Number 4, kind of the same thing, combining like terms, although we do have this little detail of a minus in front of a parenthesis. In case you've forgotten, when you have a situation like this, you do have to distribute that minus sign. So this becomes 4i minus 8, and then we have a minus distribute to another minus. It turns into plus I. Now we combine like terms. 4i plus I is 5i. Minus 8 has no like term, so I just bring down minus 8. And there's my answer, 5i minus 8. Although you may see the answer written this way, negative 8 plus 5i, and that just goes back to this a plus bi, which is kind of a format or a form for complex numbers. These are both right answers. It doesn't matter which way you write it, but this way might come up. Let me check the answer key and see. Yep, they did it with the imaginary part second. So real part first, imaginary part second. Let's do number 6. So here we do not have a negative to distribute. It's a plus sign. We distribute a plus sign. It doesn't change anything. So we can just rewrite this problem like that and then combine like terms. Negative 7 plus negative 6 is negative 13. And then negative 4i and another negative I is negative 5i. Again, in the back of your mind, you say, okay, I, it's this imaginary number. It's the square root of negative 1. It's weird. I've never seen it before. But for the math you're doing right now, I is a variable. You're combining like terms, and that's all there is to it. So you don't have to be bothered by all that extra detail, all those extra details. Negative 13 minus 5i, there it is. Okay, this next one, it's more of the same. It's combining like terms. There's just a lot of steps thrown in here. This first set of parentheses doesn't really do anything. In the second set of parentheses, we do have to distribute a negative, so we get plus 3 plus 6i. And now you just look for like terms. Negative 7 minus 3 is negative 10, plus 3 is negative 7. And then negative 2i plus 6i. Negative 2 plus 6 is positive 4i. Again, treat I like a variable. Do basic math. There it is. Number 10. Now we're getting to a power. Negative 5i squared. So this is like squaring both of these things. It's negative 5 squared. Oop, my pencil is dying. Times I squared. So I got to plug my pencil in to give it a little juice and just sort of talk for a minute, and hopefully you don't get too distracted. All right, so that negative 5i squared, we apply the square, apply the power to the negative 5 and the I. Negative 5 squared is negative 5 times negative 5. Negative 5 times negative 5 is positive 25. I squared, technically, is negative square root of negative 1 times square root of negative 1. But we don't want to do that kind of math. We don't want to think of it that way. We just want to refer back to what we set up here. If you ever have I squared, it automatically becomes a negative 1. So this works out to equal negative 25. Or at least it should. Let me scroll down and check. Where am I? Number 10. Wow, okay, right there. Negative 25. So that's how you could handle a power. Your number 9 is a lot like my number 10. Use my example to help you do number 9. Number 6, where did I get that from? Number 12, there's a 6 in it. That's how smart I am. Negative 4 times 6i. Well, this is just multiply. How would you do negative 4 times 6x? You just multiply it and call negative 24x. Same thing. Treat I like a variable. That's negative 24i. What about what we just learned in the last problem? Well, there's no power here. There's no exponent. So you just leave your answer, negative 24i, and that's it. Let me check number 12 and make sure. And yeah, right there, negative 24i. Number 14. This is multiply. Now, when you multiply a bunch of things together, usually it's best just to go left to right. So negative 7i times negative 8. Negative 7 times negative 8 is positive 56i. And then bring this down. Positive 56i times negative I. Positive times negative is negative. 56 times, remember there's always a 1 in front of a variable, so 56 times 1 is 56. I times I is I squared. Just like if you have x times x would equal x squared, I times I is I squared. And then once again, if you ever have I squared in any answer, change it to -1. I squared is -1. So this works out to be -56 times -1, which is positive 56. Plug my pencil back in, get it charged up, check the answer, and there it is, number 14. And it looks like, what did I do? Skip checking 12? Yep, -24i. So, in fact, looks like 10, 12, and 14. All right. Good. Let's look at number 16. 2 plus 6i squared. Now, what does it mean to square something? When you square something, you multiply it by itself. So 2 plus 6i times 2 plus 6i. How do you do this? Well, remember this is called FOIL, and you just did some work on it. So we multiply first 4 outside plus 12i, inside plus 12i, and last plus 6 times 6 is 36, I times I is I squared. Plus 12i plus 12i, we can combine that and get 24i, plus 36i squared, but I squared, remember from the last problem, anytime you have I squared, you have to make it -1. I squared always turns into -1. So this becomes plus 36 times -1. So that's 4 plus 24i. What is 36 times -1? That's -36. And look, 4 minus 36. Those are those are like terms. We can combine them. What is 4 minus 36? That'd be -32 plus 24i. A lot of steps, a lot of work to show here. You can do some of the math in your head, I totally get it, but you're going to need to show your work. You're going to have some steps you would write out on a problem like number 16. Your number 15, very, very similar. Let me check real quick. And there it is. All right, let's look at 18. 18 is another FOIL problem, so multiply. First, -8 times -8 is 64. Outside, -8 times -8i is positive 64i. Inside, -7 times -8 is positive 56i. And last, -7i times -8i is positive 56i squared. If we put these two terms together, because they're like terms, we get 64 plus what? 120i, yeah. Plus 56 times -1. What did I just do? I turned I squared into -1. You're supposed to always do that. 56 times -1 is -56. And then these two are like terms that go together. 64 minus 56 is 8. Bring down the plus 120i. And there you go. Number 18 is 8 plus 120i, I hope. Yes. Very good. Oh, only a couple more and we're done. Number 20. All right, this is multiplying. Tell you what, just ignore this and multiply these together. 8i times -7i is -56i squared, right? 8 times -7, -56. I times I is I squared. But I squared is -1. And -56 times -1 is positive 56. Now the thing I told you to ignore, just bring that down. And then continue to multiply. So we have the distributive property here. 56 times -5, positive times a negative is negative. That's what, 250 plus 3,280. And then 56 times -2 is minus 112i. Use a calculator if you're not going to do all that multiplying in your head. Totally okay. But that is the answer for number 20. Right there. One more and we're done. Number 22, 3i to the third power. Well, what we have here is, when you raise something to the third power, you multiply it by itself 3 times. 3 times 3 times 3 is 3 cubed. I times I is I cubed. What is 3 cubed? 3 to the third power. 3 times 3 is 9. 9 times 3 is 27. What is I to the third power? Well, fortunately, I told you in the notes, I to the third power turns into negative I. There's the explanation there if you need to see it. But the short, sweet part of the story is anytime you see I to the third, you just turn it into negative I. Finally, 27 times negative I is negative 27I. And that's the answer. Boom. All right, so for a bunch of the math you're going to do, you're just going to pretend I is a variable and do it like you did any other algebra problem that you've done in school. Then you'll get to some of these down at the bottom, the second page here, bottom of the first page, that are a little difficult. Wow, I made a new word. Yes, you still treat it like a variable. I times I is I squared, FOIL, stuff like that. But you have this extra fact that if you ever have I squared pop up in a problem, you do have to change it to -1 and then simplify it. So that happens over and over and over again. I squared turns into -1. Here I squared turns into -1. This I squared. It happens problem after problem after problem. I squared turns into -1. And then finally, again, if you have an I cubed turns into -I. All right, I'm going to stop there. If you have trouble, contact me, let me know, and I will do my best to help you out. Otherwise, have a great rest of the day.